Barry is a chartered civil engineer and has a wealth of experience in construction, off-site manufacturing, asset management experience, and across many different ranges of civil engineering. In addition to his experience in civil engineering, he has worked with timber engineered buildings, including domestic housing, hospitals, schools, multi-story apartment blocks, and most recently modular construction for housing. Barry has most of his experience through Ireland, the UK, and Europe. But he has recently returned to Australia, and he is currently acting as the technical representative for WoodSolutions, the industry advisory body for the timber industry. So we'd like to welcome up Barry to the stage.
Right. Thank you, Ken. My name's Barry Brunton. I'm here from WoodSolutions. I'm a representative for the South Australian team. And tonight I'm going to give you a general overview of CLT buildings and tall timber buildings. That's going to include some of the general benefits, some of the preliminary design considerations, some of the benefits that we see from timber itself throughout the life cycle of a building, and something that might whet your appetite in terms of financial information and costings and how they stack up against other construction techniques. Okay, so first of all, WoodSolutions, who are we? We're funded by the Forest and Wood Products Australia, and we have the world's most visited timber website. Now, I've just come from UK and Ireland. I've spent 17 years over there, and over there they've got TRADA, the Timber Research and Development Association, and they're a fantastic organisation with loads and loads of resource. But what's really good about WoodSolutions is the information that's available on the website is all free to download. They've got loads and loads of great technical guidelines that's free to residential homeowners, for decking, builders, architects, engineers, students. It's a really, really good resource. I'd encourage you to tap into it. Okay, so before my time coming back to Australia, in 2016, the National Construction Code changed to include timber buildings into a category classed as mid-rise buildings. So mid-rise buildings, we're talking about structures that are up to an effective height of 25 metres or approximately 8 stories high. These types of buildings include apartments, hotels, office blocks, and Jeremy will be talking about a case study after myself. WoodSolutions have put together a document, it's technical guide number 37 for information, recommend you download it, and it gives you a pathway to satisfying this code. And that pathway will include things like inclusion of automatic sprinkler systems, the fire protection of the timber, very important, insulation types, cavity barriers, and the really important detailing surrounding that. And they're available for download. Okay, alternatively, if you don't follow that pathway, that deemed to satisfy condition, there's alternatives for you. There's the performance solution. So for example, if you had a structure that you wanted to expose a timber soffit to a ceiling, or timber lined walls, or some other architectural feature that meant you couldn't satisfy that deemed to satisfy option, you can go down the performance solution, and there's guidance documents to help you with that. Okay, so what is CLT? It's had a number of names. It's been called massive timber or mass timber construction. It's been called CLT or XLAM. It's even been called jumbo plywood, which is not too far away from the truth, really. Effectively, what CLT is imagine a large homogeneous panel, significant in size, and effectively it's made up in layers. And the layers are effectively boards laid one after the other on a flat bed. On top of that board will be a layer of adhesive sprayed on top of it. And then the next layer of boards are placed orthogonally or perpendicular to the first layer, similar to plywood. And then the next layer, again, placed 90 degrees to that. So very, very similar in its properties with plywood, and that gives it an inherent stiffness and its strength. Okay, so headline benefits, it's got all the things we love about timber. It's got a very high strength to weight ratio, and CLT products are manufactured off-site. So we're talking about CNC machinery and all the good manufacturing processes that deliver lots of value to a project. Minimum 3 layers, 3, 5, 7, that sort of layers, and the outer layers and the orientation of those outer layers sort of dictate the primary span of the panel itself. In Australia and New Zealand, the laminate thickness, typically 20 mil, 35 mil, 45 mil. Europe, slight variation from that, and the reason I mention Europe is that some product of CLT is brought into the country from Europe. Okay, panel sizes, panel thicknesses. Okay, so it could be anything from 60 mil thick to maybe half a metre in depth. So half a metre in depth, you may be talking for a big span floor, a large span of the floor. The widths can be between 600 mil and 3.5 metres. So 3.5 metres, if you think about a commercial building, typical floor to ceiling height might be about that sort of region, 3.5 metres. And the panels can be made up to 18 metres long. Now, manufacturers can make that size of a panel, but it comes with a caveat in terms of transportation. Transportation is going to be a constraint. If it's coming from Europe, for example, you might be limited to a 40-foot shipping container. So you're talking about approximately 12 metres there. Alternatively, if you find a local supplier from the place of manufacture to your site, there might be traffic restrictions that might also limit the length of panels. Okay, so general properties of CLT. We've talked about the strength and stiffness, the strength to weight ratio. It's also similar to reinforced concrete in the fact that it's two-way spanning, so it can span 2 directions. If you think about a typical floor joist, it would be single spanning. It would span from just one direction, whereas this can span in both directions. Now, however, I say that most panels are designed to span in the primary direction. The adhesives that are used in the process is a polyurethane. These are effectively now formaldehyde and solvent-free. There's a link with formaldehyde and carcinogens. And the species, most of the species available in the markets are softwoods. In Australia, you're talking about a radiata pine. In Europe, it's a spruce. And there are rumblings about hardwood options for CLT. Now, I'm not sure if it's commercially available, but I know that in the industry they are talking about it. One of the other good things about CLT and the cross-lamination is that it increases the splitting resistance of timber. It does. And also, the breadth and depth of the connections can be quite robust. It gives you the overall surface area, generates a really good connection. Okay, so where's CLT being used in Australia? It's been used for hotels, domestic housing, apartments, student accommodation, agricultural buildings. So a really vast array of options has been used for it. And it's almost limitless, you'd think, when you look at that little list there. The benefits of using CLT as a product in your building. In this sort of day and age, it's hard to ignore the responsibility that we have, particularly with projects and the landmarks that we leave behind. When you think about the greenhouse gas emissions that come from the production of concrete, steel, and compare timber beside it as a stark contrast, it's one that's hard to ignore and something that will generate lots of interest, no doubt. Okay. All right, so considerations. If you've got a project, you're at preliminary stages, first thing I do is recommend engage with the manufacturer, because they're going to give you really good information in terms of overall sizes, information regarding the delivery and the construction techniques. They're going to talk to you about maybe things like window openings and door openings and how they can be best configured. Should they be machined out with a CNC router in the manufacturing environment? Or is there another way of optimizing it and configuring it differently? So they'll give you options and guidance. They'll also talk to you about site constraints we mentioned earlier. But at the same time, as part of the manufacturing process, for them to give you the best efficiencies, they probably want to go for a large panel. They are. And there's two benefits to that. There's efficiencies in the price of the product you receive, and also the other benefit is the project benefit, which is the reduced hook time on the crane. And for mid-rise structures, that's a significant factor not to forget about. Some of you, maybe most of us in the room, will recognise the top part of this slide. Typical stud wall construction on plan, looking at a couple of studs and some noggins between, lined with 2 layers of plasterboard to achieve a certain minimum fire rating. There are various permutations available for CLT and mass timber within this code change, and that could be something like the bottom part of the slide, which is a single layer of 16mm board in comparison to 2 layers of on the framed wall. The manufacturers as well, they're going to give you guidance on terms of the connection types, whether they be metal brackets, there could be even epoxy resin glues or other variations. And if there's any structural engineers in the room, you might be asking questions like the floor and diaphragm action, and the CLT can offer those benefits and provide that diaphragm action that's needed in buildings, and also in the shape and form of shear walls. So for those parts of the building, like lift shafts, stairwells, that need that robustness and give the overall strength to the building, CLT, there's loads of case studies where that's been the case. Service zones for follow-on trades. So think about electricians, so sparkies, plumbers, other tradesmen coming afterwards. Typically in a reinforced concrete building, they're going to have their arms above their shoulder with a percussive drill, drilling into masonry, mechanical fixings and chemical fixings just to get that sealing in the surface zones. In these sites, you've got tradesmen walking around with screw guns, and that brings benefits in terms of program time and safety as well. Okay, acoustic considerations. CLT has got a natural damping ability, and if it's detailed correctly, and I say that it's really quite important, if detailed correctly, your CLT building can exceed the minimum building regulations. You'll see on the right-hand side of the slide, a floor panel's been offered onto a wall panel, and you see a little damping strip there. Not unusual to see that in certain types of construction. That'll help to reduce flanking noise. Okay, timber, well-being, healthy for the environment. Okay, we know about trees, and they release oxygen into the atmosphere via our plantations. In turn, the tree will absorb the carbon in the form of carbon dioxide, and that carbon dioxide will get retained within the tree and therefore into the engineered wood product. And effectively it's sequestered, is the phrase that's used a lot, sequestered into the wood product. So if you've got a large CLT panel, a big significant panel, it's going to store a significant amount of carbon, and therefore it is a renewable material from that perspective. Today on your seats, I've left a little study from Pollinate, and they carried out a study on behalf of the FWPA in regards to timber in the workplace and how it affects the productivity of workers. This survey is sort of carried out with 1,000 people. One group had exposure to less than 20% of timber surface area, another group had exposure to greater than 60%, and the findings were really significant. Signs of higher concentration, higher levels of satisfaction, higher levels of productivity, less sick leave. There's a real potential that could lead to higher levels of staff retention, and all those good things that employers need to be interested in. I'd recommend you take it home to your wife, husband, partner, even your boss, and think, maybe we could change things in our work environment, even in the home environment. Okay, renewable material, I mentioned it earlier on. What do I mean? Okay, so Australian softwood plantations have the capacity to grow 30 to 40 cubic metres of timber a minute. When you strip away the bark and the branches and all of that good stuff is recycled and used for mulch, paper, animal bedding, biomass fuel, it leaves you with approximately 11 to 15 cubic metres per minute of engineered timber products that can be used. You then convert that into some of the structures that exist in Australia today, and you've got a growth rate in the period of hours which is significant in comparison to other products that might be available. Concrete and steel, they just can't have that sort of renewable aspect to them. Costs and benefits, conscious of time here, but some of the things that a CLT building will bring to your project will be faster delivery, lower preliminary costs, and reduced size of foundation, and therefore reduced cost associated with the foundation also. The follow-on trades, they can start immediately. So in reinforced concrete structure, you're going to have to wait for the slab to cure to get to a certain compressive strength before you can release the props and therefore release the other trades. Not the case with CLT. The other trades can get straight at it. This brings program benefits and no doubt cost benefits as well. Also, the fact that it's an offsite product means that there's shop drawings available, so ready to insert into your BIM models if that's something that you're using in anger. Lower preliminaries. It's a substantial cost to any project is the project management costs, the site security costs, site accommodation and cabins, and even scaffolding and the likes. The build time with these off-site manufactured products is significantly quicker, and therefore that cost becomes significantly less as a result of it. WoodSolutions have gone through a couple of exercises and they've got Technical Guide 26 and 27, which gives you a case study of between a massive timber building and a reinforced concrete building. And they can display, we can display the cost benefits from using a timber building. You combine that with the earlier slide regarding the greenhouse gas emissions, and it's hard to ignore that this is certainly an option for structures of the future. Program. Typically, you see the programs finish 20% quicker. And that's as a result of the fast installation time, the fact that it's off-site, it fits together like a big jigsaw puzzle, but robust in nature. Andrew Waugh in London from Waugh Thistleton Architects uses Murray Grove as a case study. And his estimate is that this was 30% faster to put together than a reinforced concrete structure. With a significantly reduced workforce as well. So a team of 5 workers. It also has benefits from a safety perspective. Typical crews for off-site manufactured timber products can install somewhere in the region of about 80 square metres a day, and that includes walls and floors and ceilings. Okay, now there are possibly some arguments you say if I bought a metre cube of timber and a metre cube of concrete, the prices might not be comparable. But at the same time, one of the considerations is the weight. There's a significantly reduced weight in a timber building than a reinforced concrete building. And as a result of that, you've got smaller foundations, and as a result of that, you've got smaller costs associated with that. And in a mid-rise building, somewhere between 4 and 8 stories, that can be a significant number. Okay, this slide, when it came across my desk, was an odd one for me, particularly when I see the costs associated with landfill levies in Australia. The trend is certainly only one way there, and it's not going to get any better, I don't think. I think the trend's always going to be upward, and in fact, what I understand is that 40% of Australia's waste to landfill comes from the construction industry. And what I'd say about this is if you're using CLT as an option for your next project, these guys are using manufacturing processes, so lean engineering, Kaizen type processes, all of this good stuff that's come from the car industry and other manufacturing industries, and they're driven towards zero waste. You go to a site with an off-site engineered product and the waste is significantly less than what you see tramping around maybe the sites you do see now. So thinking about the costs of a CLT building and taking away a cost per cubic metre of timber versus a cost per cubic metre of concrete, you've got to look at the whole life cycle of the project rather than just the cost of the product itself. So in summary, we've got CLT as an option for your next project or the developments that are ahead of us in Adelaide and South Australia. There's the safety factors, there's the speed of construction to consider, there's clean, reduced number of deliveries to site, significantly reduced, and it's renewable. And I'll leave you with this last slide here is how you use timber in your next project.